Hi, everybody. Welcome to Algebra 2. Today we're going to be doing a general review of geometry topics. So what we're going to do is we're going to look at, if I can find my mouse, we're going to look at a couple of different topics that you covered in geometry, but maybe we should review them before you take the ACT. So first of all, I have a few tips for you. The first one is whenever you're taking the math part of the ACT, sometimes you'll see an option of none of the above or cannot be determined or maybe not enough information. Usually, that's not the answer. So if you're in a situation where you'd have to guess on a question, don't pick either one of those because most of the time that's not the right answer. Then I have been told like I went to an ACT training a couple years ago and I was told that the last 20 questions, the answer is more often an A or an E. So let's say that you are taking the test, it's a time test, you're running out of time, you've got to guess the last 5 questions. My advice is to guess either all E's or all A's. Now, you're probably going to miss a bunch of these just because you totally guessed, but a couple of people have analyzed it and I've been told that the answer at the end, last 20 questions on the math test, are usually A's or E's because I don't know, maybe it's because people usually guess C's, but that's what I've been told. And they said it's only true on the math. Now, diagrams are usually to scale. At the beginning of the ACT, it'll say diagrams are not necessarily to scale. Well, usually they are. So if you do have to make a guess, then use the picture and help you guess. And I think that's all the general tips I have, but we'll see as we go. So the first thing we're going to talk about is coordinate geometry. There are some formulas from coordinate geometry that you do need to have memorized. The first one is the slope formula. And when I say memorize, I don't mean memorize it the day before the ACT. This is something that you should start memorizing now, so that way when you go to take the ACT or another standardized test, this formula is just something you know like the back of your hand. And you can pull it to the front of your brain and use it whenever you need. But the slope formula is y2 minus y1 over x2 minus x1. So you might see a question like about slope like this one right here below. What's the slope of the line passing through the points negative 3, 7 and 11, 0? Well, the x1 would be negative 3, the x2 would be 11, the y1 would be 7, y2 would be 0. So to find slope, I would do 0 minus 7 over 11 minus negative 3. That would be negative 7 over 14, which is negative a half. Another formula you're going to need to be well aware of is oh wait, here's more slope stuff. Other things you need to know about slope. Sorry about that. Other things you need to know about slope are parallel and perpendicular properties. So lines that are parallel have the same slope. So this question right here, what's the slope of any line parallel to the line 1/2 x plus 3x equals negative 5? Now, when it's written in this form, this is called standard form, I can't see what the slope is until I rewrite it, maybe the y equals mx plus b form. That is that slope-intercept form. If I can get it in this form, then I can see that that slope is m. So let's try that. So I'm going to rewrite this. First of all, I'm going to write the whole question. 1/2 x plus 3y equals negative 5.
Have your attention. Students may eat lunch.
So 3y would be negative 1/2 x minus 5. And then if I divided everything by 3, y would be negative 1/6 x minus 5/3. So to answer the question, what is the slope of any line parallel to this one? Well, any line parallel to that one is going to have the same slope. And the slope of this line is negative 1/6. So to answer that question, the slope would be negative 1/6. Question 3 says, what's the slope of any line perpendicular to the line 6x plus 9y equals 12? Well, perpendicular lines are lines that intersect at right angles. So they intersect like this, like a T. Perpendicular lines have opposite reciprocal slopes. So opposite means change the sign, positive or negative to positive. Reciprocal means flip the fraction. So then if I'm trying to find the slope of a perpendicular line, first of all, let me rewrite this equation so that's in the y equals mx plus b form. So I'm going to take 6x plus 9y equals 12. I'm going to solve it for the y. So subtract 6x on both sides. 9y equals negative 6x plus 12. Divide everything by 9. Negative 6 over 9 is negative 2/3. And 12 over 9 would be 4/3, I believe. Yes. Okay. So if I'm looking for a perpendicular slope, then I need to look at the slope of that line. Where's my highlighter? Slope of this line is negative 2/3. Perpendicular, I'm going to take the opposite, so change the sign and then flip the fraction. So the slope of a perpendicular line would be positive. Where's my pen? There we go. Positive 3/2. Another formula you'll need to memorize is the distance formula. Distance formula is this. Distance equals the square root of y2 minus y1 squared plus x2 minus x1 squared. And again, this is the distance formula. So if you know 2 points, you can use the distance formula to calculate the distance between those 2 points. So it might just be a straightforward distance question, or it might be something like question 4 that we see here, where it says quadrilateral ABCD is drawn in the standard XY coordinate plane as shown below with points E and F on AD. So E and F are on this bottom line. Point G is the center of the rectangle. How many coordinates long is AG? So how long is this? Well, I don't know the coordinates of G, but I do know that G is in the center of the rectangle. So they're talking about this rectangle right here. Well, I want yellow. There we go. This rectangle right here. G is in the center of it. And so that will help me find the coordinates. So let's see. Looks like this length goes from 6 to 12. So C is at 12. Let's get a green to write these. 12, 4. So halfway in between 6 and 12 is where I'm going to find the x coordinate for G. So what's halfway between 6 and 12? Let's see, average those two. 6 plus 12 is 18. 18 divided by 2 is 9. So G's at 9. And then as far as height goes, let's see, from 0 to 4, halfway between 0 and 4 is 2. So G's at the point 9, 2. So I need to find the distance from 0, 0 to 9, 2. So let's find the distance, use the distance formula. Square root, and again, here's the formula, y2 minus y1 squared. So y2 would be 2, y1 would be 0, so I would do 2 minus 0 squared plus x2 would be 9, x1 would be 0, 9 minus 0 squared. So d would be the square root, 2 squared is 4, 9 squared is 81, 4 plus 81 is 85. So the distance is the square root of 85, and that is how long AG is. So that's the length of line segment AG. Square root of 85. And another thing you'll need to know, or another formula you need to be aware of, is the midpoint formula. The midpoint is the middle point between 2 points. That's why it's called midpoint. There is a formula for the midpoint. I'll take the x's, x1 plus x2, and divide them by 2. That's an average of the x's. So you average the x's. And then you do the same thing with the y. So y1 plus y2 divided by 2. And that's how you get the coordinates for the midpoints. Average the y's. And that's also what we did to find g. We found the x midpoint and the y midpoint. That gave us g because it was in the center. So grab that, and then let's look at this question right here. In the standard coordinate plane, what is the midpoint of the line segment that has endpoints 3, 8, and 1, negative 4? So if you like to think graphically, I can kind of sketch this. 3, 8 would be a point in the first quadrant, 3 up 8. 1, negative 4 would be here about. So I'm trying to find the coordinates for the point, whoa, let's call that one. Coordinates for the point in the middle of those 2 points. So to find that midpoint, I'm going to take the x's and average them together. So 1 plus 3 divided by 2. And then the y's, negative 4 plus 8 divided by 2. So that would be, let's see, 4 divided by 2 is 2. 4 divided by 2 is 2. So 2, 2. So right in the middle, 2, 2 is probably about right there. Now I sketched it, so it looks a little bit like it's off center, but it's the middle. And then one more let's look at this question. In the standard XY coordinate plane below, 3 of the vertices of a rectangle are shown. Which of the following is the 4th vertex of a rectangle? Now this one, I just like to see what it looks like. If the point is at 3, negative 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So it would be about right here. Does that look like it could be a rectangle? Maybe. So maybe that one. We'll star that one. If it was at 4, negative 8, it'd be down here. That would make something that looked more like a trapezoid. So not that one. So kind of go through these, but it does end up being F. Kind of plot and guess. The other things that you can check to make sure, because sometimes you'll be able to plot and you might have to choose from two things you'll want to check if you're trying to find out that 4th coordinate. Opposite sides of rectangles are parallel. So you could check the slopes of the opposite sides, and the opposite sides need to be equal or congruent. So you could check the distance, find the distance for the opposite sides as well. Then the last thing that you don't want to forget about coordinate geometry, I'll just add this at the bottom. We just covered this, but just a reminder, that circle equation, that's pretty popular. So just remember that the circle equation in the coordinate plane x minus h squared plus y minus k squared equals r squared, where the center is hk and the radius is r.